We've seen SpaceX's Starship, NASA's SLS, Rocket Lab's Electron, and more. But today, we're exploring spaceplanes, and we're going to be seeing whether they could transform how humanity could travel beyond Earth. So first, let's know what spaceplanes are. Spaceplanes are basically spacecraft that launch like rockets or aircraft, then land horizontally on conventional runways. Like, let's say, there could be spaceplanes that launch on a rocket, so with a booster, they launch vertically off the ground. And then they do their mission in space, and when they come back, they land on conventional runways that are usually used by planes. So rockets currently dominate in the current era because they're powerful while being very expensive, complex, and not yet fully aeroplane-like operations. Rockets can't be used, like there can't be a rocket launch every half an hour currently. It's maybe once every alternate day. That's what we're aiming for, to get it to the cadence that aircraft are at. And to do that, we'll need space planes. Rockets currently dominate the market today as they're more simpler in conventional design, as the people who first made a rocket, they made it easy for everyone else to understand, which kind of makes everyone else use the rocket design itself. Now we're going to talk about the early experiments, like the X-15, which had proved winged vehicles could briefly reach space and glide home. The North American X-15 is a hypersonic rocket-powered aircraft formerly operated by the United States Air Force and the National Aeronautics and Space Administration, also known as NASA, as part of the X-plane series of experimental aircraft. The X-15 had set speed and altitude records in the 1960s, crossing the edge of outer space and returning with valuable data using aircraft and spacecraft design. The X-15's highest speed, which was 7,274 km per hour, was achieved on 3rd October 1967, when William Knight flew at Mach 6.7 at an altitude of 31 km. This set the official world record for the highest speed ever recorded by crewed, powered aircraft and remains unbroken. During the program of the X-15, there was a total of 12 pilots who flew a combined of 199 flights. Of these total pilots, 8 of them had flew a combined 13 flights, which met the Air Force spaceflight requirements by exceeding the altitude of 80 kilometers, thus qualifying these pilots as being astronauts. Of those 13 flights, 2 met the FIA definition, which is 100 kilometers high of outer space. The X-15 was based on a concept study from Walter Dornberger for the National Advisory Committee of Aeronautics of a hypersonic research aircraft. The request for proposal was published on 30th December 1954 for the airframe and on 4 February 1955 for the rocket engine. The X-15 was built by 2 manufacturers. First of them was North American Aviation for the airframe in November 1955 and Reaction Motors for building the engines in 1956. So that's interesting. 12 pilots, 199 flights. Not just 40, 50 flights. 199. And it was just those 12 pilots doing all of those. And he even got space rated, like Spaceflight rated by the Air Force. Then, in the late 20th century and the early 21st century, the space shuttle had showed reusable orbital spaceplanes were possible, but the operational costs had remained extremely high. We all know the space shuttle, the STS launches. There was all the ones like Columbia, Challenger, Discovery, Atlantis, and Endeavour, with a prototype of Enterprise used only for atmospheric tests, which makes a total of 6, but there were main 5 ones that everyone knows. And there was Columbia and Challenger, which were both lost, with Challenger being lost in 1986 and Space Shuttle Columbia being lost in 2003. This is because of some anomaly in the sky, which had unfortunately blown up the ship and killed the 7 astronauts on board. If you want to know more about the space shuttle, go check out the Wikipedia page. It's quite trustworthy, that one. And just do some research online. It's pretty obvious. Then there was more modern projects, which tested smaller reusable vehicles, which are suggesting some aircraft-style space operations, which might eventually become practical. There were ones like Dream Chaser by Sierra Space. It's an American reusable lifting body spaceplane, which was developed by Sierra Space, as I said. It was conceived as a crewed vehicle, while it's still being developed in a cargo configuration known as the Dream Chaser cargo system, for missions to the International Space Station under NASA's Commercial Resupply Services program. Development of the Dream Chaser began in 2004 as a project of Space Dev, which was acquired by Sierra Nevada Corporation in 2008. In 2021, the program was transferred to Sierra Space, a subsidiary spun off from SNC as an independent company. The Dream Chaser spaceplane is designed to be launched on top of a typical rocket and land like an aeroplane on a runway. The design has heritage going back decades. Currently, the Dream Chaser will resupply the ISS with cargo. Per the company's website, a crew version is planned for a later date. Sierra Space was contracted on the CRS-2 to perform resupply missions to the ISS. Being a September 2025 contract change, Sierra Space only needs to perform a free flight demonstration, with NASA optionally booking resupply missions. So the thing is, it's not had any launches, just 4 atmospheric tests. And they want to do ISS resupply missions. And with the new International Space Station plans of it going until 2032, if it does go to then, do you really think Dream Chaser will be ready by then? As will it be able to even make one resupply mission before the death of the ISS? We can only see what comes in the future. The advantages of spaceplanes include rapid reuse, runway landings, potential airline-style operations, and possibly cheaper routine access to orbit. So the routine access to orbit, cheaper part, is what SpaceX is aiming with their Starship. But I don't believe they can do that. Look how big of a vehicle that is. How cheap can you really go with that to orbit? You need some type of space plane that can do that. That can be launched on top of a smaller rocket, land like an aircraft, launch on a smaller rocket, go into space, deploy the payload in orbit, and land like an aircraft on a runway. Think about how much cheaper that is than going for recovery and all that. It's like Falcon 9's booster recovery plan, where they just land on a drone ship or a landing pad instead of having to go recover it at sea. That's basically the same thing as a space plane such as Dream Chaser. You just land on a runway. That makes recovery much easier. But there are still major challenges that remain. First of all, in the re-entry time, there would be extreme heat, with hypersonic aerodynamics being needed, and the efficiency of the propulsion would need to be high. And always there would be structural weight limitations, as you can't have it that heavy, as it would be counterintuitive of the money that you're spending to put that into space compared to the money you're getting from the payloads. If you don't know what re-entry is, it's when, let's say there's a spacecraft is in orbit right now, which is a continuous free fall around Earth, which makes it never come back down to the ground because of gravity. And let's say it starts deorbiting on purpose or not on purpose. So now it will start re-entering into the atmosphere. They'll re-enter into the atmosphere slowly and steadily, especially with these space planes, which are aerodynamic. So it will be very slow re-entry. And during that re-entry time, there will be intense temperatures across the whole re-entry time until they get onto low enough altitudes. And if it's for a long period of time, they have to endure that temperature, which makes things difficult. So if we're looking further ahead, future space planes might hover vertically like science fiction spaceships, yet still land horizontally. Like, what I mean by this is, have you seen the sci-fi spaceships in Star Wars, etc.? If you have, you will know what I'm talking about. They launch on standstill. So envision a spaceship. Something that looks like Dream Chaser. Maybe a little more sci-fi-ish. And it's just sitting on a helicopter-sized pad. Then imagine it hovering up with its thrusters. And then once it reaches a certain hover height, maybe 5 or 10 meters high, it starts its back thrusters / engines and soars into sky horizontally without needing the use of any rockets. And then it would land maybe in a hover like flat or on a runway, which is going to probably be the future in a few centuries. Currently, we're just hoping for the current space plane designs, such as Dream Chaser, launching off a rocket, landing on a runway. That's currently our aim, but we'll see how long it takes. Whether rockets or space planes win this fight, the real goal remains making space travel more routine. Currently, we see airplanes flying more than every hour, because if you count all the airports in the world, we're flying more than every hour, maybe even a takeoff every 1 or 2 minutes, actually a few minutes, yeah. That's what we want rockets to be like. And the easiest way to do that is probably with space planes. I don't think it's possible to have even 3 Starship launches a day. That's Elon Musk's goal, getting 1,000 launches a year. 365 days in a year, around 2 to 3 launches a day. I don't think that's possible. Look how big of a rocket that is. We need space planes for this. Once it's out of the concept phase, we'll see it in the space industry. Yes, it might have a few fails, like the first few Starship launches, and then you'll have some successes, fails, successes, but that's all part of the learning process. Just as Gene Kranz said, failure is not an option, it is a stepping stone to success. So if you like this episode of us diving deep into what space planes are and why they might be the future of spaceflight, can you please give me a hand and subscribe to me on YouTube and follow this podcast wherever you get your podcasts. And if you like my podcasts, go check out my website as well and whatever else I do, as well as my YouTube shorts. Until next time, keep exploring the stars. Thank you.